Hello, good evening, everyone. This is Rosemary Akoth, and I'm going to take you through part of our assignment one. And let me begin from number 6. So, number 6, we're given that 382 people like ice cream, then 362 like cake, then the total number of people were given as 500. So, they want us here to find those who like both ice cream and cake. So, when we get the probability of those who like ice cream, cake, minus those who like both, our total probability should give us 1. So when we substitute that in this formula, we end up with, this is 744 out of 500, minus now this number we are looking for of those who like both cake and ice cream, it must be totally 1. So when we substitute that at the end of it, we come up with 244 people as those ones who like both cake and ice cream. That's what that question wanted. So coming to number 7, we're given that the box contained 5 green balls, 3 black ones, then the 7 red balls. So in a box that one had a total of 15 balls. So we were told that these balls were rolled 2 times without replacement. So they wanted a probability of growing the same color of balls from the box. So when you draw, this is what the box contains. When we make the first drawing, here we shall draw 5 for the blue one, 3, then the red one, 7. So when we remove 5 from here, here remains 4, here maintains, here blue reduces, then on the third one, the red reduces. So when we draw for the second time, this is what we come out with. So they want a probability of drawing the balls, but which of the same color. So we shall pick the ones that are both green, both black, then both blue. After that, we add up their probability to come up with this, which is a probability of drawing balls of the same color. Then moving on that, they gave us an experiment of tossing a coin several times, and they told us that the experiment ends when the first head appears. So when we continuously like toss the coin, these are some of the possible outcomes we come up with. So they tell us that the experiment ends when the first head appears. So at the first, we can have a head. Here we can have a tail, then a head, tail, head, tail, head. So this one comes as our sample space. So here they ask us, is the sample space discrete or continuous, and why? So here the sample space is discrete because the outcome can be listed one by one, even though they are infinite, but we can list that at the first tossing we get a head, the second one head, a tail. Yeah. Then the last question on this, that when tossing a coin infinitely many times, each outcome is an infinite sequence of heads and tails. So they wanted us to determine, is it infinite, or is it discrete or continuous, and why? So when we toss a coin infinitely many times, each outcome is an infinite sequence of heads and tails. So we can toss here and end up with head, tails, head, tails, head, tails. Then we can toss again and end up with the heads only or the tails only. Here we can have a mixture of the heads and tails. So this becomes now our sample space, the outcomes of those infinite tossings. So the set contains all infinite sequence of heads and tails, and this implies that since this outcome cannot be counted, the sample space is not discrete like. But for the first case, here it is discrete because each outcome can like be listed one by one. Thank you.